Hello everyone, welcome to my channel. So today we are going to do Leetcode daily, not a daily challenge, but the weekly challenge and all four questions. So one by one in all four videos, I will be telling you about all four questions. So now let us head over to the first question, that is find the distinct difference array. So here let us first read this question, then about the examples, constraints, and then finally the coding part for the same. So let us go ahead reading this question. So here you are given a zero index array num of length n. The distinct difference array of nums is an array diff of length n such that difference of I is equal to number of distinct elements in the suffix nums of I plus 1 till n minus 1 subtracted from the number of distinct elements in the prefix nums of 0 till I. Then we are required to return the distinct difference array of nums. Note that nums of I till nums of j denotes that the subarray of nums starting at the index I and ending at the index j inclusive. Both I and j are included. And then particularly if I is greater than j, then nums of I till nums of j denotes an empty subarray. So this was all about the question. Here the thing is that we are required to check for the prefix sum till a particular ith index, and we are required to check the suffix sum till that particular ith index, and we need to subtract that prefix sum, uh, and it should be means basically that suffix sum which is there, that should be subtracted from our prefix sum. So that's the thing which we are required to do at every ith index in this particular question. But and you can clearly see that this is easy level question. So the way they have stayed here, like that only we are required to do. So in that context only, the constraint would also be not much high. As you can clearly see here, the constraints are also till 50, and the terms of I will also go till 50. So basically, even the n square solution would work. But the thing is, if we are well known with any n order of n solution or n log n solution, we can go ahead with that as well. So today I will show you the order of n solution. But now comes the part that first we are required to check for the suffix sum and the prefix sum, and then finally doing the subtraction and giving the answer for that particular index. So now here what we are required to do is, see, till here our prefix sum would be 1 itself, then here 3, like that only a prefix sum would be there. And if the things are reversed, then it would be a suffix sum. But here one thing is there which they have clearly mentioned, that the elements should be distinct, and those distinct elements some should be there. See, here all the elements are already distinct, so here there won't be any issue. But here you can clearly see that 2 is occurring 2 times, 3 is occurring 2 times, right? So here we are required to eliminate those from our prefix sum or suffix sum, and then we are required to calculate what the prefix sum and suffix sum is there, and then we are required to subtract. So this is what this question is. Now comes the part. See, um, in the first thing which we will be doing is we will be calculating our prefix sum, and second thing will be we will be calculating our suffix sum, and the third thing would be clearly that we will be directly doing prefix sum at that particular ith index minus suffix sum at that ith index. So this is what we will be doing. But here the twist is that here those prefix sums which are there or elements till now should be distinct, and here also same should be there. All the elements should be distinct. So this is the only twist which they have added in this question. Now comes the part that how we are required to check for this distinct elements. See, either we can compare it that what till now if that has occurred or not, or we can directly use some data structure which can give us the distinct elements, and that for that context we can directly use here unknown set or set. So that's the thing. So here in my coding part I've used set for this thing, and how I've used set is I can directly go ahead by storing elements till now. So by itself it will only store the distinct elements so far, and I will be directly putting the size of that particular into my prefix sum. So that's the thing which I will be doing, and because of that only I will be easily able to get my required answer. See, here the context is that here 1 is there and then 2, then 3. So till now, we will be able to get uh, here at the first moment, we are if we go for the index 0. So here in the prefix sum, we will be just having one element. And in the suffix, we would be having till now 4 elements. So that's why when we do 1 minus 4, so answer would be minus 3. So that's what they have done. Then when I is equal to 1, means basically at this. Till now we have 2 elements. So that's why prefix is 2. But here suffix would be 3. So that's why minus 1 is the answer. So it is like clear cut for the for distinct elements. But if here comes the part for the non-distinct elements, means like here, if we see 3 is itself a distinct element here. So prefix would be 1. But for the part of suffix, here we can clearly see that 2 occurs 2 times, right? So that's why only 3 is being taken. So here 1 minus 3 is there. Here you can clearly see it is 1 minus 3 rather than 1 minus 4. So that's the thing. And like that manner only we will be checking ahead for each and every which is there. And here basically prefix sum and suffix sum basically indicates the number of distinct elements which we have um, stored so far, not the exactly prefix sum of the elements which are there. So that is also one thing here. So now the next thing is that how we are required to code it. We can, I've already told that prefix sum, suffix sum, and then at the end we need to subtract. But now comes the part that while doing this thing, we will be using three loops, right? So basically three-part solution it would be. So rather than using a three-loop solution, we can directly modify it into a two-loop solution, basically a two-part solution. And that how we can do is because suffix would be like we need to start from the end for storing our required distinct element so far. But for the prefix sum and for storing the answer at each index, we are required to go from starting to end, right? So that thing we can do in one loop itself. So in that context, our solution could easily become a two loop solution. So now here, how we can go ahead is here we will be taking answer initialized with 0 and its size would be n. Now next part, first here we are taking the set for the suffix. And here, starting from the end, going till 0, we will be inserting element into our set. Here, one more thing is that rather than using set, we could use another set as well. I will just show you. If we use that, because the thing is, we just need a distinct element, else there is like no need of being ordering the same. So it can clearly go ahead with order of n solution. Because of set, then the solution would be n log n. So now here, then suffix of I, here we will be storing the size of the set. All the distinct elements so far we have. So that would be stored. Then our prefix set would be there. In that we will be inserting the same. And then first thing is that till now whatever size we have been stored, that we will be storing in our prefix distinct. And in our suffix distinct, we will be first checking that is that I plus 1 greater than or equal to n. If that is the same, then at that moment, we will be directly having 0, else we will be having the value of suffix of I plus 1 at that moment. And our answer basically includes the subtraction of prefix minus suffix. So that's what we are doing. And at the end, we will be returning our answer. So in that context, here because of set, we are using n log n because your sorting is ongoing. But here it is n and here also it is n. So if we eliminate this n log n from set to unordered set, then that could be easily achieved. So it will be directly becoming order of n time complexity solution. And the space complexity is order of n because we are using these sets. So that's the thing. So let me do it in unordered set only. So here, now this solution is completely order of n solution because we are using unordered set, because we were not requiring this what we say sorting in the same, as we just want the distinct elements. So this was all for this particular question. If you have any doubt, you could comment it down, and if any other suggestion, that also you will comment. So this was all. Thank you.